All right, so we're going to do the last section of the functions unit. It's talk about graphs of functions, but the most important one, the one I want to focus on, is distance time graphs. Okay, so a distance time graph is essentially, it's a normal graph. The time is the x-axis and distance is the y-axis. The reason this graph is different from what you've done before is it has a lot of weird patterns that make sense when you think about them, but can be difficult to wrap your head around initially. So we're going to go over what those basic patterns are. I really recommend using this website. It has this little game here where basically you click and drag on the little person, and then it creates a distance time graph based on this little person's movement. And so by doing that, you can experiment and kind of see for yourself how it works, like what happens with a person and how it relates to the distance time graph. But that being said, I'm still going to go over the basics so you can understand. So let's just really quickly think. Distance time, when it's talking about distance, it means distance away from start. So when I say start, it's going to be different in different situations. My questions, I usually think about home. Home is the start. So if I'm starting at home, I would start at 0, 0. And then just say the school was 10 meters away and I wanted to walk towards it. Basically what would happen is time is going to keep passing. So if these were seconds, time would pass. And as I walk, there's going to be a line. If I change speed, or if I stop, or if I go back towards home, the line's going to change. So for each section of the line, you're going to have to be able to explain what is happening in some level of detail. So I'm going to go over with you the patterns of what's happening. So let's do the most basic first. Let's say I was standing at home. Okay? Home is at 0 distance, and if I don't move, my distance is not going to change. So I'm going to stay at 0 distance. But time is going to pass. So what will happen is you actually get a horizontal line. So this would mean that I stood still for however many seconds that is. Okay? That's what horizontal line means. However, let's say that I started walking away from home. I started at home, but then when I walk away, that means distance is going to increase. Time is also going to pass as time goes by, so it's going to get a diagonal line. Now, I want to show 3 different diagonal lines. And we'll do one more. Okay, so if we look at these 3 lines, and let's make the red one the same length so we can see what's going on. They all walked for the same amount of time. They all walked for 1, 2, 3 seconds. But what you'll notice is the amount of distance they traveled was different. The blue one went 1 meter per 3 seconds. The red one went 3 meters per 3 seconds. And then the green one went 6 meters per 3 seconds. So what you can see is that the steeper, as you can tell, this is pretty steep, going steep and steep. The steeper the line is, it means that they're going fast. If the line is very shallow, it means they're going slow. If it's somewhere in the middle, usually like this kind of line, it's going to be like average or whatever. Now, these are relative. Next unit, we'll talk about how to calculate the actual speed, but for now, I'm okay with you just saying fast, slow. The other words you can use is like run or like crawl or walk, something like that to signify speed. Now, the other thing we have to understand is direction. So in this situation, in all 3, we were walking away because home is at 0. Home is always at 0 distance. So if I'm standing at home, I am 0 meters away. But let's say we started 4 meters away. So I'm standing right there at the start at 0 seconds. I am not at home. I am 4 meters away. If I walk further away from home, my distance would increase. So the line would go like this. What you'll notice is if you're walking away, the line always goes up. Up doesn't mean faster. Up just means the distance is increasing. As we talked about before, the steepness of the line indicates speed. So both of these lines are walking away, but this one's steeper, which means it's going faster. So this would maybe go walking away and then saw a bear and started to run away. However, so let's put this here, away. If the distance is decreasing, that means we're going towards. So in this situation, the green part would be towards home. So I started over here. I walked away from home for a while. Then I started running away from home. I stopped, ran back towards home, got about like halfway there, and then walked the rest of the way because, I don't know, I was tired or something. So up is away, down is towards. The other thing we need to understand, when we're talking about these diagonal lines, that means it's a constant speed. You are going the same speed all the time. From here to here, from here to here, here to here, the whole entire thing is constant. But we don't always go constant speeds. A lot of times if you think of a car, when you start your car and start driving, it'll go slow initially, but then as it speeds up, it'll start to go much, much faster, which means it's doing more distance in less time. So you're going to get curves on your graph. So if I'm going slow, it would be this kind of a line. But cars don't just go slow and then suddenly go fast. That would be like walking, and then the next step you start running. People can do that on their feet. Cars can't do that. So if the car was going slow but getting faster every second, it would look like this. Slow, but starting to get faster and faster and faster and faster. So what you can see here, it's a very shallow line. That is slow. But then as time went on, the car started going a much greater distance away in a small amount of time. This is fast. Another way you could look at it is if you had a graph that looked like this. So if it was this. So first I want to say, where's the steep part? This or this? So obviously this is the steep part, which means the car is going fast. And then here, it was going slow. So this car was going fast and then started to slow down. So this would be like you're driving on the highway here, and then you put on the brakes, and eventually you got to a flat line, which means you stopped. Cars don't stop immediately unless they like hit a wall. So that would show slowing down and then stopping. Now again, both of these arrows are going up. So in both situations, they're driving away. We could do the exact same thing, but have them driving towards. So here, we have a car going nice and slow, warming up, and then going faster, faster, faster. Or we could have a car that starts off going really, really fast and then slows down to a stop. Okay? The only other thing we want to think about is a vertical line. So let's think about what this means. This person is, I don't know, let's make it even easier to see, okay? So here. At this point, the person is 4 meters away. And then at this point, they are 0 meters away. To go from 4 meters to 0 meters away, it took them 0 seconds. So what does it mean to travel a distance in 0 seconds? It means you teleported. And people can't teleport. That is not possible. So you should never have vertical lines on a distance time graph. And what you'll notice is this is not a function, which is why it relates to this unit. Sorry, not a function. All the distance time graphs you ever look at will always be functions because you cannot have vertical lines, so they'll always pass the vertical line test. That's the basics. It is very complicated, but all the graphs will always be made up of these parts. Horizontal lines, diagonal up or down lines, and then curvy lines. Your job is to try and make a story. So I'm really quickly going to run through some stories for these, just so you can see. This person stood still and did nothing all day. They just stood in the same spot because they never moved. This is 3 different people running in a race. Green ran really fast, red ran like medium speed, blue was walking, going slow. They all went 3 meters, and it took them, they all ran for 3 seconds, but they ran different amounts of distance. They were all running away from home. This guy starts away from home, he's at the store, and then he walks further away from home to go to his friend's house. He realizes he's running late, so he starts to run, gets there, realizes his friend wasn't home because he saw through the window, because he instantly runs back the other direction. Then he goes really slow all the way home because he gets tired. This one, you have, let's ignore this part, okay? You have a car, it's starting away from home, it's driving further away from home, it's slowly speeding up and getting really fast as it gets up onto the highway. This one, again, we'll ignore this part. I have a car pretty far away from home, heading towards home. He's going really slow, not even moving at first, and then speeds up gradually, getting really, really fast as he heads towards home. And then the teleport doesn't make sense. You can't have a person teleport. So that's the basics. You should practice by looking at stories and trying to make graphs, and looking at graphs and trying to make stories for them. And honestly, try and make them silly, like with bears and stuff, because it's more fun.